Lesson 2.7 is solving absolute value inequalities. So in this lesson, we're going to be dealing with inequalities that have absolute values in them. So we're going to be solving or isolating the absolute value portion by itself on one side of the inequality first, and then we will set up two different inequalities that represent that situation. So the absolute value of 5, for an example, the absolute value of x less than 5 is an example here. The absolute value of x can be less than 5, or it can also be greater than -5. So there's two situations there. So when we go to solve absolute value, there might be multiple steps. So we're going to isolate the absolute value term first, and then we'll set up the two different situations that can occur. So starting with example 1, you're going to solve absolute value equations just like you do before, or inequalities just like equations. You're going to isolate the absolute value expression when solving the absolute value inequalities. So for this first one, we have the absolute value of x plus 3 is less than 12. So first I'm going to isolate this absolute value of x. So I'm going to subtract 3 from both sides. 3 minus 3 gives me 0, so I'm left with the absolute value of x, which is less than 12 minus 3, which is 9. So now I have the absolute value of 9. So I'm going to have two situations here. The absolute value of x is less than 9. So either x is less than 9, and then the second situation is x is greater than -9, because we can have two situations occur. So the first one, you drop the absolute value symbols and write it exactly as is. For the second, you flip your inequality and change this to the negative value, the opposite. So our two cases here is x is less than 9 and x is greater than -9. So to graph this, we have -9, 0, and +9. We're going to have open dots at -9 and +9. So x is less than 9, so we're shading to the left here. X is greater than -9, so we're shading to the right. So we're shading in between here to represent the solution set of this inequality. Example 2, we have the absolute value, or not example 2, part B I should say. For example 1, I have the absolute value of x plus 4 is less than or equal to 2. So first set, I'm going to have x plus 4 is less than or equal to 2. That's the first case. And now to write the second case, I change the inequality. So x plus 4 is greater than or equal to, and then I change my sign, -2. So now I have these two cases, and I solve them. So I subtract 4 from both sides. 4 minus 4 is 0, so I'm left with x less than or equal to 2 minus 4 is -2. So x is less than or equal to -2. Second case, I'm going to subtract 4 from both sides. 4 minus 4 gives me 0, so I'm left with x greater than or equal to -2 minus 4 gives me -6. So then from here, I'm going to go and graph. So I have -8, -6, -4, -2, 0. I'm going to have a closed dot at -2, closed dot at -6. X is less than or equal to -2, so I'm shading to the left. X is greater than or equal to -6, so I'm shading to the right. So I'm shading the space in between. So that is what my graph would look like for part B. There are two check it out problems for you to try. So go ahead, pause the video and try these two on your own, and then resume when you are ready to check your answer. So first one, I have 2 times the absolute value of x is less than or equal to 6. So I'm going to divide both sides by 2 first because I have to isolate my absolute value term. So the 2 divided by 2 gives me 1. So I have the absolute value of x is less than or equal to 6 divided by 2 gives me 3. And now I'm going to set up my two cases. I'm going to have x is less than or equal to 3, and then x is greater than or equal to negative 3. And if you want, you can also write these jointly. You can add them or combine them together. You can write negative 3 is less than or equal to x, which is less than or equal to 3. So you could write this either or, doesn't matter. Both mean the same thing. So now I'm going to go ahead and sketch the graph. So we have negative 3, 0, and then positive 3. I'm going to have a closed dot on negative 3, closed dot on positive 3, and then we shade in between. B, we have the absolute value of x plus 3 minus 4.5 is less than or equal to 7.5. So I'm going to isolate the term with absolute value, this absolute value of x plus 3. So I'm going to add 4.5 to get it by itself. So I'm adding 4.5 to both sides. Minus 4.5 plus 4.5 gives me 0. So I have the absolute value of x plus 3 less than or equal to 7.5 plus 4.5 will give me 12. So now I'm going to set up my two cases. I have x plus 3 is less than or equal to 12. And then I have x plus 3 is greater than or equal to negative 12. And now I just need to simplify them both. So I'm going to subtract 3 from both sides. 3 minus 3 gives me 0, so I'm left with x, which is less than or equal to 12 minus 3, which is 9. Second one, subtract 3 from both sides. 3 minus 3 gives me 0, so I'm left with x, greater than or equal to negative 12 minus 3 gives you negative 15. So here, negative 15 is less than or equal to x, which is less than or equal to 9. So you can write them separate, or you can combine them into one statement. So then for my graph, okay, I'm going to have negative 15 over here, and then I'll count up by 5. So negative 10, negative 5, 0, 5, 10. Okay, so I'm going to have a closed dot on negative 15, closed dot on 9, which is about right here, and then I shade in between. So you can label that 9 so you know. So that was what your graph would look like for part B there. So a couple extra notes. The inequality, the absolute value of x is greater than 5, describes all real numbers whose distance from 0 is greater than 5 units. The solutions are all numbers less than negative 5 or greater than 5. The inequality absolute value x is greater than 5 can be written as the compound inequality x is less than negative 5 or x is greater than 5. So now we're going to deal with the greater than symbol. The inequality, the absolute value of x is greater than a. When a is greater than 0, asks what values of x has an absolute value greater than a. The solutions are numbers less than negative a or greater than a. So here we have the absolute value of x is greater than 5. So either x is less than negative 5 or x is greater than 5. So this is when we're going to have that or statement. We're going to have a left end and a right end. So now let's go ahead and look at example 2. So we have the absolute value of x is minus 20 is greater than negative 13. So I'm going to add 20 to both sides. Minus 20 plus 20 gives me 0. So I have the absolute value of x is greater than negative 13 plus 20 gives me 7. So now this is where I'm going to have the two statements. I'm going to have x is greater than 7, and then I'm also going to have x is less than negative 7. So to graph this, I'm going to put negative 7, 0, and 7. I'm going to have an open dot at negative 7 and positive 7. So x is greater than 7, so I shade to the right this time and extend my arrow because that's going to keep on going. X is less than negative 7, so I shade to the left. So that's your graph for part A. For B, we have to subtract 5 from both sides first. So I have the absolute value of x minus 8 is greater than or equal to 6. So now I have my two cases. X minus 8 is greater than or equal to 6. And then x minus 8 is less than or equal to negative 6. I'm going to add 8 to both sides. Minus 8 plus 8 gives me 0, so I'm left with x. Greater than or equal to 6 plus 8 is 14. Second inequality, I'm going to add 8 to both sides. Minus 8 plus 8 gives me 0, so I'm left with x. Less than or equal to negative 6 plus 8 is a positive 2. So then I'll set up my inequality. So we'll have 2, 4, 6, 8, 10, 12, 14, 16. I'm going to have a closed dot on 2, closed dot on 14. X is greater than or equal to 14, so I shade to the right. X is less than or equal to 2, so I shade to the left. So that is what my graph looks like for part B. So now we're going to look at the check it out problem. There are two problems for you to try, so go ahead, pause the video, try these two on your own, and then resume when you're ready to check your answer. So for A, I'm going to subtract 10 from both sides. 10 minus 10 gives me 0, so I'm left with the absolute value of x is greater than or equal to 12 minus 10 gives me 2. So my two cases, x is greater than or equal to 2, and then x is less than or equal to negative 2. So to graph this, we have negative 2, 0, and a positive 2. You have a closed dot at negative 2 and positive 2. X is greater than or equal to 2, so you shade to the right. X is less than or equal to negative 2, so you shade to the left. So that's your graph for A. For B, we have to subtract 1/2 from both sides first. So you get the absolute value of x plus 2.5. Plus 1/2 minus 1/2 gives you 0. So this is greater than or equal to 4 minus 1/2 is 3.5. Then we're going to have our two cases. So x plus 2.5 is greater than or equal to 3.5. And then x plus 2.5 is less than or equal to negative 3.5. I'm going to subtract 2.5 from both sides. 2.5 minus 2.5 gives you 0, so you're left with x. Greater than or equal to 3.5 minus 2.5 leaves you with 1. Second inequality, subtract 2.5 from both sides. 2.5 minus 2.5 gives you 0, so you're left with x. Less than or equal to 3.5 minus 2.5 gives you negative 6. So for your graph, we're going to have negative 6, negative 4, negative 2, 0, and 2. There's going to be a solid dot at 1, so filled in. Filled in dot at negative 6. X is greater than or equal to 1, so I shade to the right. X is less than or equal to negative 6, so I shade to the left. So that is your graph for part B. Now we're going to look at example 3. So it says some fire extinguishers contain pressurized water. The water pressure should be 162.5 psi, pounds per square inch. But it is acceptable for the pressure to differ for this value by at most 12.5 psi. Write and solve an absolute value inequality to find the range of acceptable pressures. Graph the solutions. So the water pressure should be 162.5 psi. It can differ by at most 12.5 psi. So we're going to let P represent the actual water pressure. So the difference between P and the ideal pressure is at most 12.5 psi. So if I take my pressure and I subtract 162.5 and take the absolute value of that, it's at most 12.5. So the biggest it can be is 12.5. So it can be equal to or less than. So less than or equal to. So we have the inequality, the absolute value of P minus 162.5 is less than or equal to 12.5. So I'm going to set up the two cases. So you have P minus 162.5 is greater than or equal to negative 12.5, and P minus 162.5 is less than or equal to 12.5. So now we're going to solve. You add 162.5 to both sides, so that gives you 0, so you're left with P. Negative 12.5 plus 162.5 is 150, so P is greater than or equal to 150. And then over here, add 162.5 to both sides to get P by itself. 12.5 plus 162.5 gives you 175. So P is less than or equal to 175. Close dot on 150, close dot on 175. And then you shade in between. So the range of the acceptable pressures is between 150 and 175. There is a check it out problem for you to try. It says a dry chemical fire extinguisher should be pressurized to 125 psi. But is it acceptable for the pressure to differ from this value by at most 75 psi? Write and solve an absolute value inequality to find the range of the acceptable pressures. Graph the solutions. So the pressure should be 125 psi, and at most 75 psi is where it should be differing. So setting up our inequality here, I'm going to use x for my variable. So x minus 125, the absolute value of that is at most, so less than or equal to 75. So the absolute value of x minus 125 is less than or equal to 75. So now I'm going to set up my two cases. I have x minus 125 is less than or equal to 75. And then x minus 125 is greater than or equal to negative 75. So I'm going to add 125 to both sides. Minus 125 plus 125 gives me 0, so I'm left with x. Less than or equal to 75 plus 125 gives you 200. And then the second one, I'm going to add 125 to both sides. Minus 125 plus 125 gives you 0, so you're left with x greater than or equal to. And then negative 75 plus 125 will give you 50. So x is greater than or equal to 50. And then I have to graph the solutions. So here if we have 0, 50, 100, 150, 200, 250, and 300. So I'm going to have a solid dot on 50 and 200. Okay, it's filled in because we have that equal to. X is less than or equal to 200, so I'm shading to the left. X is greater than or equal to 50, so I shade to the right. So I'm shading in between these two regions. All right. Example 4. So when solving an absolute value inequality, you may get a statement that is true for all values of the variable. In this case, all real numbers are solutions of the original inequality. If you get a false statement when solving an absolute value inequality, the original inequality has no solutions. So this is similar to when we solved our equation and we got no solution or infinitely many solutions. The same thing applies here with our absolute value inequalities. So for A, I'm going to start. I have the absolute value of x minus 6 plus 7 is greater than 2. So I'm going to subtract 7 from both sides. The absolute value of x minus 6, 7 minus 7 gives you 0, is greater than negative 5. So here, all absolute values are positive. When we take the absolute value of anything, the distance from 0 is always positive. So that means any number I put in for x there will always be better or greater than a negative number. So in this situation, all real numbers are solutions. So if you get your absolute value term to be greater than a negative number, that means you're going to have all real numbers for your solution. B, we have the absolute value of x plus 12 minus 5 is less than or equal to negative 6. So I'm going to add 5 to both sides. So I get an absolute value of x plus 12 minus 5 plus 5 gives me 0. So I have less than or equal to negative 6 plus 5 gives me negative 1. Remember, absolute values will always give you a positive value. So it cannot be less than 0, or it can't be less than a negative number especially. So here I have an absolute value that must be less than or equal to negative 1, which can't happen. That's a false statement. So here, this is going to have no solutions. There are 2 check it out problems for you to try, so go ahead, pause the video, try these 2 on your own, and then resume when you're ready to check your answer. So for A, we have the absolute value of x minus 9 is greater than or equal to negative 11. So I'm going to add 9 to both sides. So I get the absolute value of x is greater than or equal to negative 2. The minus 9 plus 9 canceled out to 0. So I have the absolute value of x is greater than or equal to negative 2. So here, all absolute values are always going to be greater than a negative number. So here, our answer is going to be all real numbers. For B, we have 4 times in the absolute value. We have x minus 3.5 is less than or equal to negative 8. So first I'm going to divide both sides by 4. So I have the absolute value of x minus 3.5 is less than or equal to negative 2. An absolute value can't be smaller than a negative number because it's always going to be positive. So in this case, there is no solution.